day, students. How is it going for all of you? I hope you're doing pretty good, safe, and healthy. I am Teacher Shar, your teacher broadcaster for Science 8, Week 1 of Quarter 2. The things that we're going to learn today is anchored on our most essential learning competency, where after going through this lesson, you are expected to explain how movements along faults generate earthquake using models or illustrations. Specifically, you are expected to describe the formation and causes of faults, how faults generate earthquakes, and identify the different types of faults and explain their relationship, as you already understood by that time the relationship between them. Now, can you still remember what had happened around 7:28 in the morning and 12:22 noontime on Sunday, February 7 this year? What did you do? How did you feel about it? Can you share your experience? Before we'll proceed to our lesson, please free your mind from any thoughts that would disturb you, because the key to a better understanding of the lesson is focus. Done? Very well then, students. Let us now proceed for us to get acquainted with earthquakes and faults and learn more about them. Last October 29, 2019, our city experienced one of the strongest earthquakes in the past decade. According to the United States Geological Survey, or USGS, fault is defined as a fracture along which the blocks of crust on either side have moved relative to one another, parallel to the structure. It is a break in the Earth's crust along which significant movement has taken place. Can you still remember what natural phenomenon occurred in Bohol in 2017 that resulted to surface rupture? That is right. Bohol suffered a devastating earthquake with a magnitude of 7.2, which led to a significant movement of the ground. This ruptured ground is now called the North Bohol Fault, or Inabanga Fault, that caused the displacement which is since then known as the Great Wall of Bohol. Faults are breaks in the Earth's crust where rocks on either side of the crack head slide past each other. Sometimes the cracks are small and thin with barely noticeable movement between the rock layers, while others could be hundreds of miles long and can be seen from space. But how are these faults formed, or what causes their formation? In the Earth's surface, a fault is formed as a crisp and rigid reaction to stress. Generally speaking, the rotation of the tectonic plates provides the friction, and in reaction to this, rocks at the surface break. The point of stress determines the type of fault that forms, and is usually categorized in three different ways: compression, tension, and shear. Suitably, these three tension points also correspond with the three forms of plate boundaries. Compression stress happens at convergent plate boundaries where two plates move toward each other. Second is the tensional stress, happens at divergent plate boundaries where two plates are moving away from each other. And the last one, the shear stress, is experienced at transform fault boundaries where two plates are sliding past each other. So, whose fault? Why Earth has so much faults? Neither mine nor yours. This time, let us learn the different types of faults. There are three basic types of faults, namely normal fault, reverse fault, and the strike slip. A normal fault occurs when rocks break and move because they are being pulled apart. As the area is stretched, the rocks move along the fault where each movement causes an earthquake. While the reverse fault, on the other hand, is a dip slip fault, which occurs when rocks break and move because they are being pushed towards each other. In reverse faulting, the compressive force causes the hanging wall to move upward relative to the footwall. The third type of fault is a strike-slip fault. It is described as the sinistral or the left lateral when the far side moves to the left, and dextral right lateral when the far side moves to the right. A special class of the strike-slip fault called transform fault. It is formed between two different plates due to the horizontal forces moving the layers of rocks parallel to the fault line. In this fault, the blocks of rocks on side of the fault slide past the other. Now you know the different types of faults with their direction of movement. Let me ask you, what happens when these faults are on the move, and what do you call this sudden movement or slipping of rock layers passing each other? Let us check if your answer is somewhat similar to what is on my mind. A sudden slip on a fault triggers an earthquake, just like what occurs when you snap your fingers. You bring your fingers together horizontally prior to the snap. Friction prevents them from going to the side while you are bringing them closer. Your fingertips move abruptly as you press sideways hard enough to withstand this pressure, releasing energy in the form of sound waves that set the air vibrating and move from your hand to your ear, where you hear the pop. In an earthquake, the same process goes on. Stresses in the outer layer of the earth force the fault's sides closer. The tension around the fault surface binds the rocks together so that when pushed sideways, they do not move instantly. Eventually, ample force builds up and unexpectedly the rocks slip, releasing energy into waves that move through the rock to create the shake we experience during an earthquake. Earthquakes happens over a region of the fault called the rupture surface. Just like you click your fingers with the entire area of your fingertip and thumb, in comparison to the fingertips, though, the whole fault plane does not fall at once. The rupture starts at a point called the focus or hypocenter, a point normally deep down on the fault plane. The location on the surface directly above the focus is the epicenter. The rupture begins to spread until something blocks it. Before going further to another term associated with earthquake, let us check. How are faults classified? What kind of motion they experience and what sense of stress they feel? How are faults related to earthquakes? When do earthquakes happen? If you're able to recall by memory the answers to these questions, that we're good to go. Tsunami, pronounced as tsunami, is a Japanese word. Tsu meaning harbor and nami meaning wave. Tsunami, as defined by Geoscience Australia, are waves caused by sudden movement of the ocean surface due to earthquakes, landslides on the seafloor, land slumping into the ocean, large volcanic eruption, or meteorite impact in the ocean. A tsunami is different from a wind-generated surface wave on the ocean. While wind-generated waves in deep water only cause water movement near the surface, the passage of a tsunami involves the movement of water from the surface to the seafloor. When the seafloor suddenly deforms and vertically displaces the overlying water, tsunami may be produced. Tectonic earthquakes are a special type of earthquake associated with the crustal deformation of the earth. The water above the deformed region is moved from its equilibrium location as these earthquakes occur under the sea. At plate boundaries, broad vertical motions of the Earth's crust will happen. In these boundaries, plates interact, called faults. For example, denser oceanic plates slide under continental plates in a phase known as subduction along the margins of the Pacific Ocean. Subduction earthquakes are especially effective in producing tsunamis. So, how are earthquakes related to tsunamis? You get an earthquake when a fault moves abruptly on ground. So, if a fault unexpectedly moves in or around a body of water, in addition to an earthquake, you can get a tsunami. Thus, when you're closer to the sea and experience a massive earthquake, that is a warning signal. Dash to the highest spot you can reach or escape inland using vehicle. So, how do we fare so far? Did you get the descriptions and explanations accurately? Great, because it's now your turn to answer the questions. This has been Teacher Shar for Science 8 on earthquakes and faults. Thank you.